Excitotoxicity is a process by which brain cells are either damaged or destroyed by entering a hyper-excited state. This process most commonly occurs as a result of degenerative diseases or as a side effect of certain types of drugs. To get a better understanding of what excitotoxicity is, how it occurs, and why it happens, we need to first understand how brain cells work. Neurons or brain cells work by sending electrochemical signals. The inside of a brain cell at its resting state is negatively charged. The outside medium, the intracellular space, is filled with positively charged ions. So there's a charge differential between the inside of a neuron and the outside of the cell. In order for a brain cell to trigger its effects, it needs to go from the negatively charged resting state into the positively charged excited state. And it accomplishes this by opening certain channels, or if you want to think of them as pores, to allow those positively charged ions to enter the cell, changing the charge from negative to positive, from resting to excited, and thereby triggering its effects, whatever those may be. After this is done, it closes those channels or pores to stop the positive charges from coming in, and then it begins to pump out the additional positive charge that it took on to reach that excited state so that it can return to the resting state and prepare for another activation. Now that we understand how that works, let's consider this situation. We get some neurotransmitters, it tells our cell to activate. It opens the gates, it lets in the positively charged ions, it enters the excited state, it triggers the effects. Now suppose those ion channels never closed, and it locked our cell into the excited state. This is what is known as excitotoxicity. Because there is now a massive positive charge where there is ordinarily a negative charge, things in the cell stop working properly. And an analogy for this might be sprinting. A cell can tolerate a positive charge, but only for a short time, the way that people can tolerate running at full speed, but only for a short time. Imagine if you were to lock someone sprinting at full speed. Of course, it's impossible because they'll get tired out, but imagine if you were to overcome those mechanisms and you're able to lock them in a full sprint for, say, half an hour. That would almost certainly kill the person. And it's the same thing with the cell. You lock them into a sprint for a long period of time. It is simply not designed for doing that. It's designed to sprint. It sprints for a short amount of time, then it takes a break, and then it sprints again. Another analogy might be to think of the cell as an ecosystem. So an example of that might be, well, for many of you who live by the water or by coral reefs or other marine ecosystems, know that recently a lot of marine ecosystems have been completely wiped out by very small changes in temperature or salt concentration or something very similar. And it parallels very well with our cell example, because in those situations you've got most creatures that are going to be resistant to those small changes in salt concentration or in temperature. Let's say the fish or other little critters that live in the coral reef. But the coral can't handle the change in temperature. So what happens is the coral dies, and then when the coral dies, the little critters that live in the coral die. And when the little critters die, the little fish die. When the little fish die, the big fish die. And it goes on like that, and the whole system is wiped out because of a small change, a small, weak link, right? And it's the same thing in the cell. In the cell, most things may be okay with the change in charge. But there are some systems that are going to be dependent on a negative charge being there at some point, and when it never comes, it destroys the system. So the cell has multiple mechanisms by which it can try to eliminate this positive charge. It can open certain pores, it can perform reactions on the ions to get rid of them, but eventually, when there is no relief, it will run out of resources. You basically have to think of the cell as almost a drowning person. It's being drowned in positive charge. And as a cell frantically tries to get rid of this charge, it ends up damaging or destroying itself in the process. That should give you a very good basic understanding of what excitotoxicity is and how it occurs. Excitotoxicity, a cell enters an excited state and is not able to get out of it. And as a result, it sustains damage or is destroyed. And it's particularly bad in brain cells because brain cells are a group of cells that after a certain age no longer divide. So at a certain age, if you lose a bunch of brain cells, the cells will not divide to make up that deficit. And on top of that, brain cells intrinsically have limited to no capacity for self-repair. So as we discuss excitotoxicity in the future, we'll talk about different mechanisms through various disease states and different drugs by which this occurs and how it occurs. Thanks for watching. If you have questions, leave them below. I'll get to them as quickly as possible. Until then, I'll see you next time.